Alright, so this video, we move to the next section, which is the angle between two straight lines. Okay, so in the previous video, we already learned that the equation of a straight line in terms of vector is r equal to a plus tv. Okay, so we already know the components in the equation, but to find the angle, the most important one is the component of vector v. Because what is a vector v? V is the direction angles. V is the direction vector. Okay, so in order to find the angle between two straight lines, so you have to find or you have to use the direction vector. Okay, for example, we have two straight lines right here. Okay, as shown in the diagram. Okay, we have V1 and we have V2. Okay, important thing is you have to firstly identify V1 from the equation of a straight line and also identify V2 also from the equation of the straight line. Okay, so by using these two vector, we can find the angle in between them, okay, which is represented by theta, and this theta must be an acute angle, okay, which is the angle that is less than 90 degree. Okay, as you can see right here in the diagram, if you observe closely, you can see there are actually two value of angle. Okay, the one that is one of it is the one that I have labeled with the red colored pen, and another one is right here. Okay, so this is the angle. So there are two angles when you have two straight line intersecting one another. Okay, so but the one that we calculate is the one that we always have the lesser value of angle, which is always less than 90 degree. Okay, then this one will be bigger than 90 degree, but this is not the one that we are gonna calculate, but we are gonna calculate the one that is acute angle less than 90 degree. Okay, so to calculate the angle, we have to refer to the formula of dot product, which is the V1 dot V2 is equal to, okay, magnitude of V1 multiply with magnitude of V2 and then cosine theta. Okay, we can rearrange this formula. Now we have cosine theta equal to V1 dot V2 divided with magnitude of V1 multiply with magnitude of V2. Okay, so to find the angle, what you have to do is you have to put modulus for these two of dot product between V1 and V2. You have to make sure that the value is always a positive. Okay, so the relation in terms of an angle between two straight line is represented by this formula. Okay, now let's look at an example. Alright, let's look at example 8.32. Okay, we start with an easy example first. Okay, given right here we have two equation of straight line, which are the R1 and R2. Okay, let's say this is R1 and this is the R2. Okay, both are in the different direction, as you can see, because the direction vector is different. Okay, this is the V for each of R1 and R2. Okay, so question wants us to find the acute angle between the two straight line. It means, let's say these two vector intercepts right here, intercept like this. Okay, this is R2 and this is R1. Okay, R2 and R1. So the acute angle will represent the angle that is always the smallest in between them. So this is the one that we are gonna find. Okay, so based on the formula, cosine theta must be equal to V1 dot V2 modulus magnitude of V1 multiply with magnitude of V2. Okay, and then our theta will be equal to cosine inverse And then, okay, magnitude of V1 dot V2. So that will be 1 multiplied with 1. And then plus 3 multiplied with 2. And then plus negative 3 multiplied with negative 4. Okay, don't forget to modulus the value. And then magnitude for V1. Okay, 1 square plus 3 square plus negative 3 square. Okay, this one we have to square root it. And another one also have to be square root. 1 square plus 2 square plus negative 4 square. Alright. So we will have cosine inverse of 19 divided with square root 19 and square root 21. So we have the value for theta, there is about 18 degree. So this 18 degree represents the angle right here, 18 degree. Also goes the same for this side, 18 degree. Okay, let's look at another example. Example 8.34. Okay, this is a quite difficult question. Okay, we are given with two position vector of point A and point B. Okay, and point P on AB is such that 2AP is equal to 2P is equal to PB, and L is the line through P and parallel to vector 3I minus 2J minus K. Okay, first let's illustrate okay the situation right here. It means first we have a 2 point of A and then point of B. Okay, right here we have point A and B. Okay, and then we are given with position vector. Okay, means from here we have a position O. So means we have vector OA and vector OB. Okay, the position vector is 2I plus 4J and minus 4K. And then B is negative I minus 2J minus K. Alright, the question says the point P on AB is such that 2AP is equal to PB. Okay, means right here lah. Okay, maybe right here. So P A to P 2AP is equal to 1 PB, and L is the line through P and parallel to vector 3I minus 2J minus K. Means right here we have another line that is passing through point P. Okay, that is parallel to a vector of 3I minus 2J and minus K. Okay, so question number 1A, find the vector equation of the line L. Okay, so vector equations mean we need to find R equal to A plus TV. Okay, for the vector equation R equal to A plus TV. Okay, R, we can keep it as R, and A is a fixed point along the line of L. Okay, what we can use as a fixed point along the line of L is the point of P. Okay, so we need to find the point of P and create it as a vector A plus TV. Okay, A plus T, and our V, the direction vector must be the one 3I minus 2J and minus K right here. Okay, we have to find the vector A. Okay, A is the point O to P. Okay, then so R equal to OP plus T 3I minus 2J and minus K. Alright, so to find the vector OP, Okay, we are given that the 2AP equal to PB. Okay, and then we can say that AP, okay, vector AP is actually 2. AP means OP minus with OA, and vector P to B is actually OB minus with OP. So we have right here 2OP, 2OA, and then OB minus OP. Okay, we can bring OP on one side. So we have 3OP equal to OB plus 2OA. Okay, we already have OB and OA. So 3OP. So vector OB is actually the negative I minus 2J minus K plus 2. And then our OA is 2I, 4J, and minus 4K. So 3OP is equal to, so it will be the 3I plus 6J minus 9K. Right, then we have vector OP is I plus 2J minus 3K. So this is the one that represent the position vector for point P. So since P is the one that we are looking for, to replace it right here, so OP. So our equation for straight line L is I plus 2J and minus K plus T 3I 2J and minus K. So that is the equation vector equation for line L to answer the question A. Alright, so what we have gained for question A is that we have a straight line of L with a point P on the line. Okay, so point P on the line. Okay, so the vector equation of the line is R equal to I plus 2J minus 3K T 3I minus 2J minus K. Alright, so what we have gained is that the R is actually a vector from the origin to any point along the straight line L. Okay, and then meanwhile OP is represented by this equation. Okay, OP, and this one is the vector V. Okay, this is the vector V. Alright, so or this also could be called as a vector A. Okay, so question B wants us to find the position vector of the 2 points on L which are at distance of square root 20 from point A. Okay, so means let's say this is our point A. Okay, this is our point A. So since the R, okay, R right here can be any point along the line, straight line L. So we can say that from A to R, the length is equal to square root 20 as the one that question B want us to find. And another one could be right here lah, another square root of 20. Okay. Okay, let's label this as another point of R. This can be called as R2, and right here can be called as R1. Okay, so question says that the magnitude of length AR, okay, magnitude of length AR is equal to square root of 20. So vector AR is equal to OR minus with OA. Okay, so OR is actually this one. Okay, represented by this vector R right here. So this is the OR. So we can say AR equal to I plus 2J P 3I minus 2J minus K. Okay, and then minus with vector OA. Minus with vector OA. Okay, vector OA is 2I plus 4J minus 4K. Okay, this is for vector OA. So we can try to solve or simplify this equation first. Okay, and then we will have it as negative 1 plus 3t I, and then plus with negative 2 minus 2t j, and plus with 1 minus t and then k. Okay, that is for AR, vector AR. So since the modulus, sorry, the magnitude of vector AR is equal to square root 20. Okay, so AR magnitude is equal to square root 20. Then AR magnitude equal to negative 1 plus 3t square plus negative 2 minus 2 and then plus 1 minus t square, and then don't forget to square root, equal to square root of 20. Okay, so we can remove the square root on both sides. So we are left with, after you expand all of the square bracket, we have 1 minus 6t plus 9t square equal to 20. Okay, so now we just have to solve for the value of t. Okay, and we have 14 t square plus 6 equal to 20. So 14 t square equal to 14. So t square equal to 1. So we have two value for t, which is plus or minus 1. Alright. So to find to find the position that is at the length of square root 20 from point A, okay, which means we have to use the vector equation of R, because OR is the direction vector. Sorry, not direction vector but position vector. Okay, just use back the value, the equation of vector equation from here, r, but now you have to substitute r with positive and negative 1. So, sorry, we have to substitute p with positive or negative 1. So, when p is equal to positive 1, so our OR is equal to I plus 2j minus 3k plus positive 1, 3i minus 2j and minus k. So you have OR is 4i minus 4k. Okay, so that is the position vector for the first point. And then another one is this could be OR1 and this is OR2. That is okay, substitute with negative t of negative 1. Okay, so negative 2 I plus 4j minus 2. Okay, so that is the answer for question B. Alright, then for question C means we have another line. Okay, another line represented with the letter M. Okay, but given in the form of a Cartesian. So we have to find the sign of the acute angle between line L and M. Okay, we already have the direction vector for vector L. Okay, let's say direction vector for line L is the 3i minus 2j and minus k. And then direction vector for M is firstly we have to modify the Cartesian equation. Okay, Cartesian equation given us the x minus 3, y plus 2 over negative 2 and equal to z minus 4. Okay, so this is Cartesian, so it must always appear as a fraction. So don't forget right here means we have over 1. So z minus 4 over 1 and also x minus 3 over 1. And each of these is equal to t. So for x component, we will have x equal to 3 plus t. And then for y component, we have it equal to y negative 2 minus 2t. And then z component is 4 plus t. Alright. Okay. So we can see if we convert this parametric equation into vector equation means we have r equal to, so 3i minus 2j and plus 4k and then plus t I minus 2j and plus k. Alright, so this is the direction vector for line M. So I minus 2j and plus k. Okay, so by using the cosine theta dot product to find the angle in between these two lines L and M, so means M dot L divided with magnitude of vector M and also magnitude of vector L. So it is equal to 1 multiplied with 3 plus negative 2 and negative 2 plus 1 and negative 1. Okay, divide with 1 square plus negative 2 square and plus 1 square. So we have 3 square, negative 2 square, and plus negative 1 square. So the cosine theta is actually equal to square root of 6 over with square root of 14. Okay, so that is cosine theta, but question wants find the sine. To find the sine, so we can relate the sine with cosine with the formula of sine square theta plus cosine square theta equal to 1. So sine theta equal to 1 minus cosine square theta and then square root. So we just substitute 1 minus square root 6 over square root 14 square and then square root again. So it is equal to square root of 8 over 14 or 2 square root 7 over 7. So that is the answer for question C.